Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of EC at MLR Institute of Technology, Hyderabad. Today I am here to deliver a lecture talk on Triggered Sweep CRO. So this is overview of my presentation. First of all, I would like to discuss the basic concept of Triggered Sweep CRO. Thereafter, I'll be taking the classification, construction of the Triggered Sweep CRO, working principle, and some of the application of Triggered Sweep CRO. So, in my previous lecture, I already discussed about the CRO. What is CRO and how it works, everything I discussed in the previous lectures. We will take a new topic which is nothing but a Triggered Sweep CRO. It is CRO, but it is Triggered Sweep. What is meaning of Triggered Sweep? Let us find out. A Triggered Sweep CRO is a type of oscilloscope where the horizontal sweep is initiated only when specific conditions are met in the input signal. In normal CRO, we have seen that once you switch on the power supply, this horizontal sweep will start without any condition. And we can also see that as we switch on the power supply on the normal CRO, a horizontal line always appears, even though you don't apply any input signal. So from where we are getting this horizontal line. So in normal CRO, what will happen? Switch on the power supply. After switching, automatic, the sweep start at the sweep start for the horizontal deflection. So in normal CRO, once again I am repeating the thing. In normal CRO, once you switch on the power supply, the horizontal sweep will start automatically without any meeting the signal condition. That is normal CRO. But in Triggered Sweep CRO, unless and until we give any condition, the horizontal sweep will not start. That is the meaning of Triggered Sweep CRO. Means we have to give the triggered or we have to give certain condition, then only the sweep will start, and that CRO will called as a Triggered Sweep CRO. So in normal CRO, we doesn't have to give any instruction for the sweep. The sweep will horizontal sweep. I am talking about the horizontal sweep. The horizontal sweep will automatically start. The horizontal sweep will automatically start. But in Triggered Sweep CRO, we have to give the instruction to start the triggered. Otherwise, the horizontal sweep will not start. It will remain in the idle state. So this is meaning of Triggered Sweep CRO. So what is the purpose of Triggered Sweep CRO? This ensures the display is stable and synchronized. The purpose of Triggered Sweep CRO is that to synchronize the input waveform and making it easier to analyze the periodic and repeating signal. So the question may arise, in normal CRO, there is no synchronization? Yes, there is synchronization. But normal CRO we are using a mostly periodic type of signal. We generally use in our laboratory to measure a periodic signal. But signals are not always periodic. It's signals may be aperiodic, like our sound wave, a video signal, etc. And if you use the automatic sweep, we will not able to capture this signal properly. That's why the triggered sweep CRO has been invented. So this is the difference between the normal CRO and triggered sweep CRO. So triggered sweep CRO will provide a synchronization to visualize the aperiodic signal. In normal CRO, without triggered sweep CRO, we can see a periodic waveform on normal CRO. But in normal CRO, we can't see properly the aperiodic signal like sound wave or any video signals, which are not periodic in nature. So in order to visualize properly the aperiodic signal, we have to use the triggered sweep CRO. What are the key components of a triggered sweep CRO? The key component of triggered sweep CRO is that trigger circuit. First, we have to take a trigger circuit. What is trigger circuit? It detects the triggering condition. We have already, I told, in order to use the trigger sweep CRO, you have to put some triggering conditioner. What are the triggering condition? Based on the signal, we have to decide the triggering condition, and it will detect the triggering condition in the input signal. Second component is sweep generator. Sweep generator is nothing but the time-based generator for the horizontal deflection. Already in the normal CRO, we have seen that sweep generator are used to deflect the signal horizontally. So, in triggered sweep CRO, first we have to design a triggering circuit, then sweep generator. Sweep generator is common in both triggered CRO as well as normal CRO. But triggering circuit will be used in the triggered sweep CRO. That is the only difference between the normal CRO and the triggered sweep CRO. Then third component, we have amplifier. In amplifier, already in the normal CRO we have seen that there is vertical amplifier and horizontal amplifier. Vertical will amplify the input signal which you want to visualize, and horizontal amplifier will amplify the time-based signal for the proper deflection of the electron beam toward the horizontal axis. And fourth component is CRT. CRT is obviously, without CRT we can't imagine the construction of a CRO. So CRT is the one of the most important part of CRO. The only difference or only additional circuit in the triggered sweep CRO is trigger circuit, and remaining sweep generator, amplifier and cathode ray tube, these are a part of similar to the normal CRO. Construction, already I told, trigger circuit, which uses the feedback to compare the input signal to a reference value, then feeds the result back to the control circuit's output. Horizontal amplifier, which reproduces the sweep signal and have relatively high amplitude and slow rise time. Vertical amplifier, already I discussed. Vertical amplifier nothing but it will amplify your input signal for the proper deflection of electron beam towards the y-axis. See, to draw any waveform on CRO, we need two deflection, horizontal deflection and the vertical deflection. Then only we can move the electron beam to draw the waveform on the signal. Then we have trigger level, which maintains a steady trace by starting the dot sweeping across the screen when the input signal reaches the same point in its cycle each time. Then we have trigger pulses, which will control the trace intensity from 0 to maximum. We'll discuss more in detail in the upcoming slides. Then we have the delay sweep, which add a precise amount of time between trigger point and the beginning of scope sweep. Then we have finally triggered sweep, which uses the input signal to generate the pulse that triggered the Sweep, ensuring the sweep is always synchronized with the input signal. So basically in 3-4 line we can understand that construction is nothing, construction of triggered sweep CRO consists of a triggered circuit, horizontal amplifier, vertical amplifier, sweep generator and CRT. These 4 components are enough to design a triggered sweep CRO. So with the help of diagram we will try to see. See, generally the signals are aperiodic. So for aperiodic signal it is better to use the triggered sweep CRO, because in normal CRO if you want to see aperiodic there will be synchronization problem with aperiodic signal. So we have to use the triggered sweep CRO. So here we can see that additional circuit in the triggered sweep CRO is the triggered circuit which is given to the sweep generator. Once the triggered circuit condition is met, it will trigger the sweep generator and it will give to horizontal plate and the electron will start moving the horizontal direction. At the same time, there is the vertical amplifier which will control the vertical deflection and the electron will also try to move in the vertical direction and a waveform might be drawn. So this is the basic construction of triggered sweep CRO. So generally this is the UJT based triggered circuit. Already we have seen that there is a charging capacitor. Once it is switched on, the capacitor once it is switched off, this capacitor get charges, and when the capacitor get charges and reaches the threshold value to turn on the UJT, it will try to discharge through this path. So UJT triggered circuit we can make using the UJT circuit, and this sweep period and retrace period or hold period we can change according to the need of signal by varying the R1 and CT value. So we will see what is sweep time. The time taken for the electron beam to move horizontally across the screen of the CRT from starting to the end, that is sweep time. It displays the waveform by correlating the horizontal movement of the beam with the time base. Time base is nothing but the sweep generator only. Adjusted using the time per division control knob. So we can change the sweep time using the time per division control knob. Then we have hold time. The brief interval after the completion of sweep during which the system stabilizes before the initiating the retrace. But what is retrace? The time required for the electron beam to return from the end to sweep back to the starting position on the CRT screen. What is its purpose? Its purpose is that it ensures that only the forward sweep is visible on the screen while the beam remains blanked or invisible during the retrace. So during retrace the screen should be blank. Working principle. Let us understand the working principle of triggered sweep CRO. So we have triggering event. This triggering event will monitor the input signal and it will wait for specific conditions reaching a voltage threshold or crossing the zero. Already in the UJT I discussed that when the capacitor charges to a threshold condition, the triggering event starts. So we have positive slope trigger and negative slope trigger. So it triggers when the signal rises past a set voltage. So positive slope trigger is that whenever the trigger voltage passes a threshold limit, that is the positive slope trigger. And negative slope trigger is that triggering is done when signal falls below a threshold value. So positive slope trigger and negative slope trigger. These are two types of triggering event. Initiating the sweep. When the trigger condition is met, for triggered sweep CRO, it is very important to meet the triggering condition. Once the triggering condition is met, the sweep generator starts generating a time-based signal. And this sweep generator will try to deflect the electron beam in the x direction. Third point is synchronization. Synchronization nothing but it will apply the triggering which will ensures that sweep start at the same point in each waveform cycle. This produces a stable stationary waveform display. So synchronization is very important in the triggered sweep CRO. If the synchronization is not done properly, we will not able to get a stable output. So before synchronization, we have to set the triggering voltage properly based on the nature of signal. Otherwise, we will not able to capture the aperiodic signal and the display will not be accurate. So triggering event and triggering voltage or threshold voltage must be set properly to meet the proper synchronization. If synchronization fails, we will not able to see the aperiodic signals. So what are the modes of triggered sweep CRO? Basically, there are three modes: auto mode, normal mode, and single shot mode. In auto mode, we can see that sweep operates continuously even without a trigger signal. It is used for non-periodic signal. Auto mode will be used for the non-periodic signal or when the trigger source is unavailable. Suppose if you have trigger circuitry problem or anything, we can switch on to the auto mode for the visualization of waveform in the triggered sweep CRO. In normal mode, what happens? It sweeps only when the trigger condition is detected. In normal mode, what happens? If trigger condition or threshold voltage which is set by the user is met, then only normal mode starts, and it is generally used for the periodic signals. So periodic signal can be visualized in the normal CRO also and in the triggered sweep CRO. But aperiodic, we have to try to use triggered sweep CRO. Then we have single shot mode. In single shot mode, we have to produce one sweep each triggering event. And where the single shot mode it is used, suppose the signal is like this, something. So we have to activate the single shot mode to capture the transient behavior of a signal. So these are three modes of operations: auto mode, normal mode, and single shot mode. What are the advantages of triggered sweep CRO? It provides a stable waveform display. It will provide a stable waveform display. It ensures the synchronization and it provides a stability. It can be configured to trigger on different part of waveform. It can be used for rising edge, falling edge, etc. Accurate timing analysis. It provides the consistent time reference for the measurements. So these are some of the advantages of triggered sweep CRO. What are the applications? In application, we can see that triggered sweep CRO can be used in the signal analysis, observing and analyzing the repetitive waveforms in the electronic circuits, troubleshooting, identifying the glitches, noise or irregularities in the signals. Design and testing. It is widely used in the design and testing purpose, which validates the performance of time-dependent electronic system. Education. It is also used in the education, demonstrating the waveform properties and behaviors. So these are some of the advantage and application of triggered sweep CRO. So in one line, we have to remember that triggered sweep CRO basically used for aperiodic signal and fast transient response signals. For normal signal or normal periodic signal, we can use the normal CRO also. Thank you.